You can calculate it.
Is it 10 meters per second?
That is correct. How do you reach there?
1 equals v minus 0 by 10.
Yes. Or v equal to u plus at. Same thing. Yes. So now they're asking, plot the distance covered by the vehicle during the nth second, n being 1, 2, 3 versus n. So if you want to draw that, the easiest thing is to do it by the area under the VT curve method, right? So let's look at it. I'll draw this graph even larger a little. So they are asking distance covered in nth second versus n, which means that if I divide this 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What is the meaning of nth second? N can be anything between 1 to 10 or even beyond.
Yeah.
So let's say, for example, I'm taking the third second. Then this is the distance traveled in third second.
Yeah.
So this is the graphical approach. You can either use a graph to solve this, or so if you want to use graph, for example, how will you find the area of this curve? It will be slightly difficult, okay?
Area
Because,
of trapezium.
yeah, you can do that. So this height will be velocity at the end of third second, and this height will be velocity at the end of fourth second.
Yeah.
Are you able to follow this?
Yeah.
So if I were to ask you, what is the area of this trapezium, what would be your answer be?
I forgot the formula for that.
Okay. Formula for area of trapezium is a plus b by 2 into h.
Yeah. So H is 1.
Yeah.
A and B are V3 and V4.
Correct. So if I were to write area is equal to half into 1 into V3 plus V4. Is that correct? Now replace this with n. Okay. Let's say the question is asking that, that's where the twist is. Plot the distance covered by the vehicle during the nth second. So this area that I'm drawing, which second is this? Is it the third, 3 to 4? So is it the third second or the fourth second?
Third second.
Okay, let's look at it again. first, second, 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 third, second, and then you have,
Okay, fourth, second.
yeah, so 3 to 4 will be fourth, second, right?
Okay.
Okay, I hope that part is clear. So that means if I want to find the general formula, that I want to find the distance covered in the nth second, let me call it Sn, then I will say half into 1 into, now notice here what the formula is, V3 plus V4 for the fourth second.
Hmm.
That means if I do for nth second, I will take n minus 1
Hmm.
plus n.
Yeah.
Okay, good. So we have arrived at least at this point. Now our job is to find what is the formula for, say, Vn minus 1 or Vn. Okay. Now focus here. In this diagram, V3 is the speed at the end of third second, or you can say after 3 seconds. Am I
Yeah.
correct? And V4 is the speed after 4 seconds. Am I correct or
Yeah.
not? So Vn is equal to speed, you can say after n seconds, or speed at t equal to n seconds. Both are correct ways of putting it. So let me write speed after n seconds, i.e. v at t equal to n seconds. Is that correct?
Yeah.
Just read it and tell me if you get it or not. So what would be the expression for Vn then?
Vn equals U plus An.
N, t being n. Good. So I can use using formula V equal to U plus At. Vn is equal to, what is the value of U in this question?
0.
Good. And A is how much?
1.
And T is how much?
And
So that will give me Vn equal to n. But mind you, there is a condition here for t smaller than equal to 10 seconds. Why is this condition there? What is the reason for this condition to be there?
plus the final velocity itself is 10.
No, see, acceleration is 1 only till 10.
Yeah.
So this formula for Vn is valid only for up to 10 seconds. Are you following? Which is kind of what you said indirectly, isn't it? So
Yeah.
this formula only valid till 10 seconds, right? T equal to 10 seconds. So let's bear that in mind. I have found the expression for V n. Vn is equal to n for t smaller than equal to 10 seconds. This is clear. And after 10 seconds, what is Vn? Any time which is greater than 10 seconds. What is the value of velocity there?
It's constant 10.
Yeah. So Vn is equal to 10 for t greater than equal to, or I should say equal to also is there, but doesn't matter. I covered that So I can say t greater than 10 seconds. Does that make sense?
Um,
Tell me.
yeah, it's
Okay, anyway, you don't have to apply the trapezium formula for the later portions. So it's your choice whether you want to independently do after 10 seconds a separate formula for distance, or you can apply this one. Doesn't matter, because I'll show you why. First, let's find the value of Sn. Okay, so for 0 smaller than equal to t smaller than equal to 10 seconds, Sn is equal to 1 by 2 into Vn minus 1. What will be Vn minus 1?
uh, would be
See, Vn is n. That's the hint. So Vn minus 1 will be,
n into n minus 1.
it will be simply n minus 1, isn't it?
Okay, yeah.
If V3 is 3, then V2 will be 2. If Vn is n, then Vn minus 1 will be n minus 1. Does that make sense? Or not?
Yeah.
You can ask me if you didn't get it. We are using this formula for distance that we derived from the trapezium area formula, right? This is the area approach we are taking. And we also concluded that between 0 to 10, Vn is equal to n. So when I write the value of Vn, I will write n. And when I write the value of n, Vn minus 1, what should I write? N minus 1 only, right?
Yeah.
Okay, good. So that means my Sn, finally the formula comes out is 2n minus 1 by 2. Only for t0 to 10 seconds.
Yeah.
Okay. Now if I go for t greater than 10 seconds, okay, I know that Vn is equal to 10. So the area, that is the distance Sn, is equal to half into, if I use this formula again, the one at the top, Vn is 10 and Vn minus 1 is also 10.
Yeah.
So essentially you will only have 10.
Hmm.
Alternatively, I mean, this is one approach. Alternatively, it is even easier to see from the diagram. If I take any arbitrary 1 second interval in this case, my area under the curve is going to be 1 into 10, which is simply 10. Are you able to see that?
Yeah.
Sure. So this area is 10.
Yeah.
Yeah, so that's what I get from the formula also. Because this is also a trapezium, by the way. And Vn minus 1 and Vn both have become equal now. Right. So both the sides of the trapezium becoming equal, this has now become a parallelogram, or even you can say a rectangle. So anyway, these are the two formulae that we are having. That Sn is equal to 10 for t greater than 10, and Sn equal to 2n minus 1 plus 2n minus 1 by 2 between 0 to 10 seconds. So that is our data that we will use now. Now coming to the question, plot the distance covered during the nth second, which is basically Sn.
Yeah.
Coming back, Sn, S4, fourth second, versus n. That means I'm looking to draw a diagram, a chart, a graph where the Sn is on the y-axis and n is on the x-axis. Okay, so going by the formula, Sn is 2n minus 1 by 2. That is the expression for 0 to 10. So let us divide it into two parts. One is 10 seconds, n equal to 10, and then beyond there will be a different approach. So if I simplify this, Sn equal to, I can also say n minus half. That's also one way to look at it, right?
Yeah.
N minus half. So for n equal to 0, so I can do 1, 2, 3, 4. Let me draw this longer. 5, 6, 7, 8, 9, 10. Okay. 11 and beyond. That we'll see later after 10. Till 10, let's see. So I have to plot n minus half. For n equal to 0, Sn is minus half, but there is no such thing as the 0th second. We have to start from n equal to 1. So n equal to 1, what is the value of S1? If this is my formula, what is the value of S1?
Half.
S2?
1.5. Yeah.
S3?
Uh, 2.5.
S4?
3.5.
S10?
99.5.
Is it? Or is it just 9.5?
Or 10. Okay. 9.5.
So what kind of graph am I getting here?
Straight graph.
Yeah, it's a straight line passing through the origin. Nine 9.5 is 19 by 2. So this is all the values that you are getting for different n. I'm plotting Sn versus n. Hope that makes sense. Right. Then after that, Sn becomes 10. So if n is 11, if n is 10, then you use the left formula, which is essentially 9.5. And if n is 11, then it jumps to 10. Okay, so that's the critical portion here. That is in the 11th second, I actually move 10 meters.
Yeah.
And after that, it remains constant. So there is a gap actually. I should not draw it like that. Let me just make it clear. S10 is 9.5 according to the formula. And then S11, because at t equal to 10 seconds, my speed is now constant at 10. So in the 11th second, I'll be moving 10 meters as opposed to 9.5 in the previous one. So there will be a sudden jump.
Yeah.
At 11, I will reach this. 12, I'll stay there. 13, 14, 15, then the graph becomes a linear curve like this. And if you were to join the graphs, then you will have to join like this. So that is the plot. So difficult question, no doubt, but I think it's good to do these kind of questions, right? Or do you do you disagree? Yeah.
I guess.
No, you'll see eventually. I mean, you have to do JEE level questions, so no doubt this will help. Okay. So anyway, do you want to repeat this or are you good?
I'm good.
Okay, good. Missed one line here.
So could you give me 2 minutes? I'll be back.
Sure, please. Let's move on to the next question. Could you read it?
A boy standing on a stationary lift open from above throws a ball upwards with a maximum initial speed he can equal to 49 meters per second.
So what is happening here? We have a lift which is open from the top. So it's something like this. And he's throwing a ball with the maximum speed he can upwards. What is that speed? 49 meters per second.
Yeah.
How much time does the ball take to return to his hands? So this part, I think you should be able to do yourself, isn't it? Or not? Did you try this one? Just
No.
give it a shot. Give it a shot.
Because v equals u plus at, and that t I got 4.9.
Right. So if you use v equal to u plus 80, v you take as 0, u as 49, a as minus 9.8. Is that what you did?
No, 10. Minus 10.
Okay. You can take 10 also, but better you take 9.8. Because can you see 49 is a, like 9.8 is 49 is a multiple of 9.8. So if you do like that, you'll get t equal to 5 seconds.
Okay. That's
So it's
10 seconds.
So total time of motion is 2t is equal to 10 seconds. That is one way. And I told you another way, right? The other day, how to do that kind of question. You say that s equal to ut plus half a t square. S is 0 because you have come back to where you started. So the displacement is 0, right?
Yeah.
And then 49 into t plus half into minus 9.8 t square. So answers will be t equal to 0 or t equal to 10 seconds. So 0, though we know that the object is starting from the hand. So it is 0 at that point. And the other answer is 10 seconds, which is our answer.
Okay.
Right?
Yeah.
Okay. Let's move to the second part, which is significantly more difficult. If the lift starts moving up with a uniform speed of 5 meters per second, and the boy again throws the ball up with the maximum speed he can, how long does the ball take to return to his hands? So in this case, what is the difference? Now the lift is actually moving up with a speed of 5 meters per second.
Yeah.
And again, the boy is throwing up the ball after the lift starts moving, of course. then how much time does the ball take to return? So what will be your approach here? If I start moving the lift, let me draw the diagram for that. If I start moving the lift upwards, lift itself is moving at 5 meters per second. And now the boy is throwing the ball with the maximum speed he can. Now how much time the ball will take to return to his hands? So what should be the approach here?
You add 49 plus 5.
So that will give me, what will it give me?
54.
Yeah, what will it be?
Uh,
Do you understand the question?
yeah. How long does the ball return? Okay. So 54 is the initial velocity,
Of
right?
the ball with respect to?
With respect to the boy.
That's not correct. The boy himself is moving at 5. The boy with respect to himself can only throw at 49.
Yeah, with respect to the lift.
But the lift is also moving at 5 with the boy.
Uh,
Hmm.
uh,
Is there no other frame of reference you can think of apart from the boy or the lift? Is there something else you're missing?
Ground reference.
Yeah. When 5 is the speed of the lift and the boy with respect to the ground. So if you were to add the two speeds, 5 and 49, that will be the speed of the ball with respect to ground, isn't it?
Yeah.
If you think about it this way, I'll call this 54 and then it has to not come back at the same position with respect to ground. By that time, boy will also have moved up. Are you following? In the
Yeah.
end, we want the ball to return to the boy's hands. If you throw the ball up, once
Yeah.
it's left,
So
it's
I
left. And then when it comes back, it will not reach the same point with respect to ground. It will reach the boy's hand who has himself moved upwards with the lift. So you were saying something?
I think we need to calculate the distance traveled by the lift as well.
That is one way to go about it. Let's do it that way. So you are doing in ground frame. We'll do both ways. I'll show you the easy way also. In ground frame, how do you calculate? Speed of the ball, u is equal to 49 plus 5, 54 meters per second. What is the displacement that the ball has to make? The displacement that the ball has to make, first we find the displacement of the lift or the boy. Displacement of the boy is, it is moving with constant speed, boy, 5 into some time t. So let me just call it 5t. Is that okay?
Yeah.
And then s of ball will be also 5t.
Yeah.
So that means you are saying s equal to ut plus half at square. 5t is equal to u 54t plus half. Acceleration is how much in the ground frame?
Minus 10.
Let's take 9.8 again and t square. Okay, so one of the answers will be again t equal to 0. Or second answer will be, if you solve this, you will find t is equal to 10 seconds again. Is that correct? You can check the calculation if you want. That one goes to the left. 49t is equal to 4.9t square. Right?
Yeah. Sure.
So that doesn't make sense, does it? Because when the lift moved, the time should have been smaller or greater, is what we would think. Is that so? Yeah, we will think like that, isn't it? But if you solve in boys or the lift's frame of reference, things become clear. Forget about that the lift is moving. Just for a second, go to the boy's frame of reference, or you go and stand in the lift with the boy and solve
Okay.
accordingly. In that case, U is still 49,
Yeah.
S is still 0, and A, because your frame is not accelerated, you can still say that A is 9.8, minus 9.8.
Yeah.
So you will have an identical equation. That is 49t plus half minus 9.8 t square. And you will get the same result, t equal to 0 or 10 seconds.
So there are two answers for this.
As I said, the 0 second is the initial point where the ball has not even left the boy's hand, just
Okay.
about to leave. So we are not talking about that point, are we? We're talking about when the ball comes back into the boy's hand. Because initially also S is 0.
Yeah.
So that will give you the answer for t equal to 0. And when it comes back into the hand, that is the 10-second time, which is the answer also to both the parts, whether the lift moves or the lift doesn't move, right?
Yes, sir.
So this brings us to a very important juncture where we can understand that a frame's movement may not affect the motion at all if we go into the moving frame. Okay. So always see if we can simplify the motion by moving into a traveling frame. Here we can also talk about non-accelerated frames are called inertial frames. We will get into this deeper later. Inertial frames, and problem can be solved by moving into the inertial frame. Are you
Yes,
following?
Yes, sir.
Without any modification. That is, you don't have to do anything special, just keep it like normal, just like we did here. Okay. Whereas, now this is the important part which you don't know yet. We'll study in laws of motion about this. That is, accelerated frames, which you will not be asked in these two chapters before laws of motion. Accelerated frames are called non-inertial frames.
Okay.
And problem cannot be solved by moving into the frame
Okay.
without the addition of an extra force called pseudo force. So this is just a side note for you. Okay. So in short, the takeaway is whenever you see that the frame is not accelerating, but it may be moving with a constant speed. In that case, you can do what we did here. Just move into the moving frame and see if that helps our case. Like we did in the train example, train A, train B, guard, driver. You remember that example? There we went into the train's frame to understand it easily. Okay. Similarly, if you remember the cycle and bus example, this one, where is it? The bus and the cycle example. Yeah, this is the one. Here also we went into the frame of the cyclist to solve this problem, right? So we have done this numerous times where we move into another frame and don't change anything. Any forces or anything are not applied extra. But side note, if the frame is accelerating, then things become different. And we will solve it in a different manner. That kind of question.
Yes,
right?
sir.
Okay. So is it enough for today or you want to do one more problem? I'm giving you the option.
Sir, I'll do that as homework, I guess.
Oh, you're tired or what?